Hello explorers and welcome to another video. Today we are doing some more Advent of Code and I have some days off, so why not do a chill video where I try to solve another of these examples. So let's jump over here and see. Your plane lands in plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area aboard the ferry, you realize that you are so early no one else has arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you are pretty sure that you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input, and the seat layout fits neatly on a grid. Each position is either a floor or an empty seat or an occupied seat. For example, the initial set layout might look like this. Now you just need to model the people who will be arrived shortly. Unfortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seat adjacent to a given seat, one of the 8 positions immediately up, down, left, right, or diagonal from this seat. The following rules apply to every seat simultaneously. Okay, so it's like Conway's Game of Life, I guess. If a seat is empty, then there is no occupied seat adjacent to it, the seat becomes occupied. Okay? If the seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat's state does not change. So if the seat is empty and there's no occupied seat adjacent to it, the seat becomes occupied. Floor never changes, seats don't move, and nobody sits on the floor. After one round of these rules, every seat in the example layout becomes occupied, because you go through all of them before you actually set a difference. After the second round, the seat with 4 or more occupied adjacent seats become empty again. And this process continues for 3 more rounds. At this point, something interesting happens. The chaos stabilizes, and further application of these rules causes no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change state. How many seats end up occupied? Okay, so let's get this puzzle input and let's save that to test 11A. So this is day 11. We will also copy this one to have as our test example. Switch over here, inputs, new file, puzzle 11 test txt. So that's that one. I guess this is a much larger one. Yep, it is. And then we need to have a class here, a puzzle 11a, and that will have a main method. And I also think we should have a new seating map class. And I want to give myself a little bit of a challenge here. We have done a lot of mapping using int arrays back and forth, but in one of the earlier examples somebody said you can do this easily with strings and just keep the lines as they are. So why not try doing this with just a list of strings? So we have a private list of string map new array list. So that's our input here. And I think the seating map is something that we will fill in, so I will not have any constructor here, but I will have something where I can add a new line. So let's take a public public void add line string like that, and then we have our map add string like that. So now we can add a new line to this input. Then we need to know how many surrounding a specific XY position that there are. So first we have this public int get number of adjacent, and then we have an X and a Y like that, and they can be zero terminated. So in that case we will want to check if map has, if Y is larger than 1, then we would have, let's see here, if it's larger than 0, then we could have something that is above. So map get 0, I'll get Y minus 1. So that's the row above. And then we can have a private check adjacent row like that, and that will take a string row and an X position. So that means that we can do check adjacent row like that and the X position. And then we do the same for Y should be available. So we do the same for Y. And we also want to have a check for Y plus 1, where if Y is smaller than the map size minus 1, right? Map size, if it's smaller, then we can still do any indexing on size, and that's not allowed because it's 0 terminated, so we need to do minus 1. So we can either do that or say Y plus 1 is smaller than the size. That might be more easier to read. So we do like that. So now we can say that we have something that will check number of adjacent. So int num of adjacent 0, and then we will add to this. Let's see here, if we go back a few here, add to this value here like this, and then we will return number of adjacent. Then we pretty much do the same for the row. So here we want to check that X is larger, and then we can say that we want to get row get char at X minus 1, And if that's equal to occupied, then 1 else 0. So that's something we can check, and then we will check for x, and then we will check for x plus 1, and do x here, and then row size. Then we will know, okay, row length. Then we will know how many adjacent there are. We also need to have a function that we can compare two things. So equals. So here we do object equal. That's not good enough. List. Let's see here. Lists. Do we have anything there? We don't have that. So what's the easiest way to check that these are equal? So we have one that object that has a list or have a map. So let's say 4. Do a simple for loop. That map size plus. Here we can return true. And if at any point that map get I is not equal to map get I, if at any point that is true, then return false. I don't think we can do like that. I think we need to do an equals on that. And string equals, they should be equal, these two strings. And if not, we will return false. I don't think we need this if the object is the same object. That seems strange. So this should give us an equals. Yeah, I think that's good. And we also want something that can give us public int. Yeah, we need to get the current char as well. So let's do a public char get character at x and y. Like that. And there we have, let's see, we do map get y get char at x. We return that. So that's how we get a character. Then we can have a public int get max x, and that will return the map first row length, and if we do a public int get max y, that's the same as map size, like that. So now I think we have everything in our map. We have added a lot of things. We can go back to this one, and we need to copy over some of the old things here so we can actually read a buffer. We read the test input, and we have our line here, and I think we can just remove everything here, and then we'll create a new seating map, new seating map, and then we take the seating map and add a line to that. So then we will have a complete seating map. So for int x, where x is smaller than the seating map, get max x and x plus plus. So that's our outer loop. We do the same for y here, like that. And here we have a new seating map, new map, like that, while the seating map does not, let's see here, don't equal the new map. Then we'll continue like that. So let's first off do the update. So first off we need a new line here. Like that. And then for each of these we will take the seating map, get number of adjacent for x and y, and if that is larger than 3, then line is equal to not occupied. So that's one of the cases. But we still need to have, I think we need to do a function here, handle seating, and it will take a map and it will return a new character here. So it will take the new map and an x and y coordinate. I think that's the best way to do this. So let's create that method. And it will take the seating map like that. And here we'll just return that character, and we will have a switch statement here for seating map get character at x, y. And if we have the case that it is not occupied, then we will check if this is equal to 0 and then return occupied. And if it's occupied, we'll do the check that we had here earlier. Return not occupied if it's more than 3, so that's 4 or more. And the last case, if it's just empty space, we will do nothing. So let's return that again. So that's the logic part, I believe. And here we will return the empty as well. Or we can have this as a default case. Then that will be happening. So there we have that. We switch over and return something. And that will handle this seating arrangement. So now that we have a line here, we will take the new map and add a line to that. So that's the new line here. I think we will need to have this down here, right? Do, while that is true. Nope, we need to have it outside. Let's see here. Up here we will need to have a new map. If this new map is null up here, so if the new map is null, then we will create a new seating map for us. We also need to switch the old one Okay, so if it's not null, we will switch them out. And we will always create a new map here. So that's something. See if we ever get down here. We will not. Sure at. That's what I wanted. Why is that not used? Haven't I changed that? That's a good indicator that something is wrong. Yes. X and Y. So let's see here. If we do this and debug it, see if we end up at the end here. I think we have some problem with our rules here, because it just flips back and forth, right? Yeah. So that's not correct. So let's go here and see what happens. We have a new map. We can't check ourselves. That's not allowed. So there we have an issue. So let's see again if we get the right value here. So the first seating should be fully, yeah? So let's look at the first line here. There we go. And oh, but we need to, okay. Here we need to have a boolean, same row. Same row, of course. And if it's this not the same row, then we will do that. And the same row will not apply for the row above and above, but it will apply here. That's the easiest way to do that. So we want to check all the values above us and all the values below us and on the side, but not ourselves. So that's what we are trying to accomplish here. So let's go in here and let's run it through once. So we have the map, and then we go into the first one here, 0, 0, and it has, so it will check number of adjacent, and it's not that, so it will go in here and say that this is the same row, and it's false, and then this is false, and that's 0 at the moment. And then we'll go in here, the row below, so it's false, same row is not true, and it has a value there. So it's 1, 2. So 2 is the number. It's not above 3, so it will not. So let's check if the map looks reasonable after the first iteration here. Doesn't really look that good, right? Everything is available again. That's not what we wanted. So they are flipping back and forth. So it's still, oh, we are getting less and less less and less seating arrangements. That's interesting. Oh. Of course. This is the issue. We should always return something. And if this is true, it should be empty, else it should be occupied. So that's what we want to do. And here we always want to return something, and if it's equal, we want to return occupied, else available. So that should be better. Let's see here. So now we have a seating map that seems reasonable. Yes, this seems much more reasonable. And you see here, that's true. This should be, yeah, it has more than 4. That one has more than 4. So I think this looks pretty good. And we actually got down here with something that looks similar to the result down here, right? Very similar. So let's do a little bit of an extra function here. Public int count occupied, just for it. So occupied 0, and then we want to have something that private int occupied line string for to char array if it's equal to hash mark. Let's see here, occupied 0 occupied is equal to 1 or 0. Add to that, return the occupied sign for each string in the map. Occupied is what we check on the occupied line for this string. Return occupied. So now we have something that could check how many occupied seats there are. So here we want to see number of occupied seats is equal to the seat map count occupied. So let's see here. It tells us 37, and here it looks that it should be 37. So now we should be able to do the same with our puzzle input and see what the result gets then. Then we get 2,289. So let's try that out. Yes! You get a gold star, I get a gold star, everybody gets a gold star. We solved it. So let's see what part 2 is. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats, they care about the first seat they can see in each of those 8 directions. Now, instead of considering just 8 intermediate adjacent seats, consider the first seat in each of the 8 directions. For example, the empty seat below would see 8 occupied seats. The empty seat below would see 8 occupied seats. Okay? The leftmost empty seat below would see 1 empty seat, but cannot see any of the occupied seats. Okay? The empty seats below sees no occupied seats. Okay, because there is nothing in the different directions. Also, people seem to be more tolerant than you expected. Now it takes 5 or more visible occupied seats for an occupied seat to become empty. It now seems to be it takes more than 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more. for the previous rules. The other rules still apply. Empty seats that see no occupied seats become occupied. Seats matching no rule don't change, and the floor never changes. Given the same starting layout as above, these new rules seating area shift around as follows. Okay. And then we have 26. So now we need to have something that can feather out to the different directions. Let's create some new functions. Public int get star adjacent. So this is feathering out as a star in each direction. We start with an x and y coordinate. Let's see here. So the easy ones are just the non-diagonal things. So what we want to check is something that is an iterator in every direction, and then we want to check for occupied on each of these iterators. We only check the first thing that we see that is not a dot in that direction. That's what I'm doing wrong here. I can't check everything. I need to check just the adjacent in any direction and see the first empty seat or the first yes. Okay. Let's go back to the drawing board here. Check direction. And then we want to have x. We don't want to have this. We want to have x, y, and an iterator. We want to have an x add and an y add, and also an x and y that we start on. So we want to get the char at let's see here. We can start with getting the row, and the row should be the map get y plus y add. So that's the row. If the y plus y add I don't think we need to iterate, actually. We can handle that. If that's smaller than 0, then we will return -1. If these two are larger than the map size -1, and we also return -1. So that's the... We need some way to indicate that we are outside of the board. That's a -1. And we also need a way to indicate that we are on an empty C. So that should be the -2. Let's do some side of board -1 and floor, let's call that -2. So here we have some out of bounds things, and then we should stop. And then on this row we want to do some checks on the X and the X add, and if they are there, they are outside of the board as well, then we can get this character, can switch on this character, so the row char at X plus X add. And here we will have the case of an occupied, we will return 1. Case of a not occupied, we will return 0. And the case of floor, we will return floor. Like that. And I think actually we can change these up. I think that's easier. So now we have something that can check a specific direction. And we also need to know... No, we don't really need to know if a direction is live, because we can check each individually until we... so int dir check, and it starts at starts at 2, for instance. It starts at floor, while dir check is equal to floor. We will check direction of X XY I0. So that's one direction. Dir check. And if dir check is equal to outside of board, if it's not equal to outside board, then we will take the count adjacent and add deer check to that. So that's one direction check is what we are doing here. So we will start and saying that where we are at the moment are floor, which is not true, but it works for this example. And then we will move in the X direction away from that direction. And there we will see that we will get a result for that. The get direction count. And here we have X, Y, and then I want to have X add, Y add. And these should be multiplied by I here. And here we want to do a lot of these checks in different directions. And the same result down here. So this is a way to trying to simplify this, but it's not easy. I understand that. But I'm trying to separate each concern here. So here we can check, for instance, 1, 0. So that will move in the X direction. We also want to check the Y direction. We also want to check the both of those. Then we can have the same loop but minus. Then we have checked 6 directions. We need to check 8. So the last ones would be these, and we go like that. So now we have all the 8 directions that we check, and then we will return that result here. So let's see if that's something that works. Missing return statement, yeah. So default here is floor. Let's try again. So first iteration, we should get everything set here, which we get. We go in here and handle star adjacent. And here we will check the first direction, which is 1. In the X direction, we will check the Y direction, which is 1 as well. Is that correct? Yeah. And we will also check that direction, which is 3. 4, that's not true because we can't move in that direction. 5, 6, 7, 8. So this is not working at the moment. That is what I can clearly say here. So let's try it again. we move there. We check here. Let's see. First, we will do one iteration. We will go down here, go into this one, here. So there starts at floor. We'll check that direction. We are not outside the board, not outside of the board. We will get that row. It's not outside of the board. See. Y is add 0. Oh, can't start at 0. Needs to start at 1, of course. So first is correct. Seating map, next one. Seems reasonable. Let's see here. Yeah. So let's move back here. Run it again. Yeah. So let's try to run this and see if we get 26, which is the correct one. I believe. Yeah. Haha! Ooh, yeah. This is exciting. Let's see what our results become here. The result here is 2059. Let's put that in and see. Yeah, you get a gold star, I get a gold star, everybody gets a gold star. Haha, we solved it. So what did I do here? Well, we changed it up a little bit. We still have the function where we check for seating as we had before. So handle, but we called it handle star seating instead. And the only thing we changed up in this function is the star adjacent. And this star adjacent, it will go through and count the check if there is a seat available in that specific direction. And the way it does that is that we say that we are at one specific position and we want to move in a direction of, in this case, 1, 0, which means for the first iteration, we move 1 to X. In the second iteration, we move 2 to X, and so on. And the same here, we go to 0, 1, so we will move in the Y direction. And then we have the diagonal here, and then we will move backwards, so minus direction for X and Y, and the diagonal. And then we need to also do the diagonals where we go plus X minus Y and minus Y plus X. So these are the different direction we will go in. The direction counter will accept floor as a state that we can be at and continue. And then it will start at 1 and check for each iteration if there is any floor on that space. And if it's not floor, it will continue to the next one. And if it's outside of the board, we don't want to count it. So that's a different state than floor, but it's still something that we don't want to happen. But if it's, we also will return something here that could be either floor, outside of the board, or an empty seat, or an available seat. And the empty seats and available seats are 0 and 1. If it's not, then it should be a floor. If we find a character here that is not empty or available or occupied, then it's probably floor. And then we have these checks up here, sanity checks, to see that we are inside of the board. So there were a lot of moving parts in this little thing here. I have been going on for 1 hour and 15 minutes to figure this one out. I will cut it down so you will get less of it. But I hope that you found this interesting, and I thought this challenge was really interesting to keep it as strings. It made it a bit harder to think about, but I still think it was a very interesting exercise. I hope that you learned something today. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues. If you have any other solution that you have come up with, please leave some code down below or just comment on my solution. And I really hope to see you in the next video.